Alright, so here we're going to use long division with multiple digits, and after this lesson I should be able to divide using the standard algorithm. Now do not let the words standard algorithm freak you out. Standard algorithm for division is long division. Okay, so basically what it's saying is when we're done with this, we should be able to use long division. So now it's important to know the parts when we're dividing. So I want you to think of these words that end in the OR. Here we go. Or the or sound. So think of a teacher. A teacher teaches. A baker bakes. So a divisor is going to divide. All right, so here we have the definition of divisor, which is the quantity that is doing the dividing. So your example in this case, I have 40 divided by 8. Listen to how that's being said. 40, oops, sorry about that, divided by 8. Okay, so that's saying that 8 is our divisor. When you're looking at a division problem in an equation form, that number that's right after the division symbol is the divisor. In long division, the divisor is on the outside. If it's in fraction form, so I would have 40 divided by 8, the divisor would be on bottom. All right, then you have the dividend. The dividend is the number that's being divided. So in this case, with our same examples, 40 is being divided by 8. 40 is the dividend. In this case, 56 is being divided by 14. And if it was in fraction form, 40 divided by 8, it would be 40. All right, quotient. The quotient is the result or the answer we get when dividing a number by another. So if I did 24 divided by 4, I would get 6, and 6 would be my quotient. When I teach students long division, I like to use this little funky sentence to help students remember their steps. So dirty monkeys smell bad. The D in dirty reminds us that we're going to divide. M, multiply. S, subtract. B, bring down. So dirty monkeys smell bad. All right, so the first thing we're going to work with is estimating quotients. And we're going to use this problem about the local petting zoo that had a total of 98,464 visitors last year. And the zoo was open every day except Thanksgiving, Christmas, and New Year's Day. We're going to estimate the average number of visitors per day. Important here is to note that we're estimating, so we're not going to use our exact numbers because we don't want an exact answer. So we're going to estimate the average number of visitors per day. So in this case, I know that it's visitors is important. Per means I'm going to divide. And then the number of days is important. The number of visitors was 98,464. And then it was a year that they were talking about in terms of days. But we also have to note that they were open every day except Thanksgiving, Christmas, and New Year's. So that's really important. So in order to find the average, we said we were going to have to divide the visitors by the days. So to estimate that quotient, we first have to estimate the dividend. Okay, the dividend in this case is the number of visitors, which is 98,464. Now, something that's important to note is that when you're not told what value to round to, so in this case, we weren't told which place value to round to until this little spot came up. When you're not told, so when you are not told what place value to round to, you always round to the largest place value. Alright, so we weren't told to round to the 10,000s in this problem, but we're going to because of the fact that 10,000 is the largest place value. So what I like to do is I like to use the dot and box method. I put the dot under the place value that I'm rounding to, and everything else goes in the box. The first number in the box, which is the 8, tells the 9 what to do. The 8 tells the 9 to round up to a 10. There's no number to the left of 9, so I can just write down my 10. Everything else in here turns into a 0, so I have to add 4 zeros behind that 10. So my estimated number of visitors is 100,000. Okay, then moving on, I need to think about, well, how many days was the zoo actually open? We noted that it was closed on Thanksgiving and Christmas and New Year's. Because of this, I have to take away 3 days. Since there's 365 days in a year, and we take away 3, that tells me the zoo is open for 362 days. So now I'm going to estimate the divisor by rounding to the hundredths place. Excuse me, sorry. Because hundreds is the largest place value. So again, the 6 tells the 3 to round up. Everything on the inside becomes zeros. So this gets rounded to 400. So now I have my 2 estimated, my divisor and my dividend, and I'm going to actually divide them. So I have 100,000 divided by 400. Now what I like to do when I have these large numbers that end with so many zeros, I like to write it in fraction form and use my little tricks. So I know that for every 0 in my divisor, I can take a 0 out of my dividend. So my problem actually becomes 1,000 divided by 4. Well, I know that 100 divided by 4 gives me 25. So because I have this extra 0, I still need the 25 because I still have this little 100 right here. Divided by 4 is the 25. And then I add a 0 on the end. So my estimated number of visitors per day was 250. Now, if I wanted to know the exact answer, I would just divide the numbers as they are. Again, my divisor has to go on the outside, and my dividend goes on the inside. So 362 goes on the outside, 98,464 goes on the inside. Now what I like to tell my students to help keep their work nice and organized, especially because we're going to get into dividing with decimals, I like to tell them to give everybody at the party a chair. And the people at the party are the numbers in the dividend. So 9, 8, 4, 6, and 4 need a chair. This helps keep your numbers lined up, which is incredibly important when it comes to place value. So now I have my little saying over here. I know I need to divide. I know 362 cannot go into 9. It cannot go into 98, but it can go into 984. Now, I'm going to go ahead and I'm just going to start by guessing that 362 times 2 might get me close. 2 times 2 is 4, 6 times 2 is 12, carry the 1, 3 times 2 is 6, plus 1 is 7. Let's go ahead and give it a shot. So I divided, I multiplied, and I got 724. Now I'm going to subtract. I got 0. 8 minus 2 is 6. 9 minus 7 is 2. 260 is smaller than 362, so I am on track. If this number was larger than 362, that tells me that I could make more groups, and so this number up here in my quotient would have to be larger. Alright, so now I've subtracted, so now I have to bring down. And I'm going to bring down a 6. So now I'm going to Excuse me. Now I'm going to go ahead and look at 2,606. Well, that's a lot larger than 984. And the furthest I've gotten was 724. So I'm going to go ahead and try 5. 362 times 5 gives me 10. That gives me 30. Plus 1 is 31. 3 times 5 is 15. Plus 3 is 18. Okay, well, I can still get closer than 1,810. So I'm going to go ahead and try 7. I know 362 times 7. 2 times 7 gives me 14. Carry the 1. 6 times 7 is 42. Plus 1 is 43. 3 times 7 is 21. Plus 4 is 25. And I know this will work because it's smaller than 2,606. So I have divided. I multiplied and got 2,534. Now I need to subtract. 6 minus 4 is 2. Borrow from the 6, it becomes a 10, and that's 7. 5 minus 5 is 0. So I am at 72. But now I have to bring down, because I subtracted, my 4. And look at that, 724. I got that up here. So I already know that this is 2. And I know it's going to work out perfectly because these two numbers match and I have 0 left over. So in this case, the exact number, so the average number of visitors per day was 272 people. Excuse my icky handwriting. Alright, so now what we're going to look at is what happens when we have a remainder. So we're going to do a problem that's going to give us a remainder, and then we're going to look at how that might impact a problem. So here I have Callie, who has 1,850 books, and she must pack them into boxes to ship them to a bookstore. Each box holds 12 books. So what we want to know is how many boxes does she need to pack all of the books? So here's my question. How many boxes will she need to pack all the books? It's important to note she wants all of the books. She has 1,850 books. We don't care that they're going to a bookstore. Each tells us we are going to divide because we're putting 12 each in a box. And I'm going to divide by 12 because I'm going to take that 1,850 and I'm going to put it into groups of 12 so I can put them into boxes. Alright, so I'm going to divide 1,850 by 12. This is my divisor. This is my dividend. So 12 goes on the outside. 1,850 goes on the inside. Everybody gets a chair. 0 gets a very large chair, apparently. There we go. Now, I need to do my dirty monkeys smell bad. Oops, bad. 12 can't go into 1, but it can go into 18 one time. 1 times 12 is 12. I subtract and I get 6. Now I have to bring down the 5. Now I go back up to the top and I divide again. 12 goes into 65 5 times. 5 times 12 is 60. I subtract and I get 5. Now I bring down my 0. I go back up to divide. 12 goes into 50 4 times. I multiply 12 times 4 and I get 48. I subtract and I get 2. But there's nothing else to bring down. So right now, because I am looking for that remainder, I stop. So my answer is 154 remainder 2. Or my quotient is 154 remainder 2. However, we want to know how many boxes Callie will need. So we have to think. How many boxes are there going to be that are full? Well, we know we can make 154 groups, which means we need 154 boxes. However, what does this extra 2 mean? Well, this tells us that there are 2 books left over. So what that means is, since she wants to send all of the books, we need one more box for those 2 books. So we can't just use 154. We have to give Callie 155 boxes, so that way these 2 books get shipped as well. They might be a little bit more lonely, but they're going to have a box so they can get to the bookstore. All right, so the next thing we're going to do is we're going to do long division with a decimal. I will give you a little bit of a warning. This goes on forever, okay? But we're only going to go, for this first example, we're only going to go 3 places out. Okay, so we're going to go 3 places past the decimal just to get the practice. Now, everything stays exactly the same. You're still going to put your divisor on the outside, which is 67, and your dividend on the inside, which is 3,098. I'm still going to give everybody a chair, and I'm still going to do my steps. So I know 67 can't go into 3 or 30, but it can go into 309. And for the sake of time, I'm just going to go through with the numbers that I know, and I know that it goes in 4 times. You will probably have to go off to the side and do some practice runs, and that's fine, right? I got to do this ahead of time so we can make it go a little faster. So I know that 4 times 67 will give me 4 times 7 is 28, carry the 2, and that gives me 268. So I've divided, I've multiplied, now I subtract, and now I bring down the 8. I know that 67 goes into 418 6 times, and that gives me 402. So I've divided, I've multiplied, now I subtract. Now here it looks like I have nothing to bring down because I don't. However, I want you to think about $7. $7 is the same whether it has the decimal and the 2 zeros after it or if it doesn't. That's because when you add a decimal, as long as you add zeros afterwards, the value does not change. So as long as I don't change the value of this number, I can continue to divide. But again, what I do to one, I have to do to the other. So if I add a decimal in my dividend, I have to add a decimal in my quotient. And if I add a 0, I have to give him a chair. And then I just continue to follow my steps. I bring down that 0. And I look how many times does 67 go into 160. Well, 67 is close to 70. 70 times 2 is 140, so let's try 2. 67 times 2 is 14, so 134. I get 6 and 2, so I know it works. And I'm going to add another 0. I'm going to keep going, and I can bring another 0 down. How many times does 67 go into 260? Well, since we were close, I'm going to go ahead and try the 3. 3 times 7 is 21. Carry the 2. 6 times 3 is 18, plus 1 is 19. I can't get any closer than that. Actually, let me double check my math here because something seems off. There we go. I've added 1, not 2. Always double check. So here I'm going to subtract. 10 minus 1 is 9. 5 minus 0 is 5. And again, I can keep adding zeros as long as I want to. Okay, and I know 67 goes into 590 8 times. And I'm going to do that off to the side just to double check my math. 7 times 8 is 56. Carry the 5. 6 times 8 is 48. Plus 5 is 43. $43.53. There we go. Okay, 4. 8 minus 3 is 5. Okay, so notice I can keep adding zeros and I can keep going as long as I want to. Right? Like I said, we're going to stop here, so I know that the answer is approximately 46 and 238 thousandths. Okay? Again, we're going to do a lot of practice with this in the next class, so don't stress if you're worried about the decimal. We'll have lots more practice with the decimals, but what I am going to have you do is you have 2 more problems, and those 2 more problems are listed on this same page, and both of these are going to work out exact. Neither of them is going to have a remainder. What I'd like you to do is I would like you to please try them, right? Put up your chairs, do your extra, multiplication and stuff on the side, take your time, so that way when you can come back on our next class, we can go over them and use them in our lesson. Right? So, as always, if you guys have any questions, make sure to write them down or email me so we can go over them in class.